Welcome, aspiring data analysts, to an essential guide on 5 key data analysis concepts that will shape your journey in data science. First, let's explore the CRISP-DM process, a cross-industry standard process for data mining, guiding data projects from start to finish. It begins with business understanding, defining what the company aims to achieve and what success looks like. Next is data understanding, involving collection, exploration, and initial checks for problems or gaps within the data. Data preparation follows, focusing on cleaning and organizing data to ensure it's ready for analysis and modeling. Then comes modeling, where we select and test various models to determine which performs best for our objectives. Evaluation is crucial, checking if results are logical and effectively meet the initial business goal. Finally, deployment involves sharing these insights or integrating the successful model into practical use. Remember, CRISP-DM isn't always a straight line. You often revisit earlier steps to refine your approach. Now, let's discuss time series forecasting. Your data must be clean and consistent before forecasting. This means no missing dates, no sudden large jumps, and everything correctly ordered chronologically. You also need to identify trends and seasonal patterns, like increased sales during Christmas. Ensure the data is stationary, meaning its statistical properties remain constant over time, avoiding significant drift. Once these steps are complete, you can build models such as ARIMA or exponential smoothing to make accurate predictions. Time series analysis is about discerning patterns in historical data to make informed forecasts for the future. Moving on to data ethics, its core principles are fairness, transparency, privacy, accountability, and security. As analysts, we must use data responsibly, collecting only what's necessary, obtaining consent, and safeguarding it. Companies uphold these by implementing clear data policies, conducting regular bias checks, and training staff. Being open about data usage fosters trust with both customers and the wider public, which is paramount. If I suspected bias in a predictive model, I'd gather clear examples and discuss them calmly with my manager. I'd explain how this bias could impact decisions, suggesting retesting the model with more balanced data. To prevent future bias, we could use a broader mix of data, reevaluate success metrics, and perform regular fairness checks. Finally, let's differentiate between regression and classification models. Both predict, but answer different questions. Regression predicts a numerical value, such as the cost of an item or next week's sales figures. Classification, conversely, predicts a category, like whether a customer will make a purchase or if an email is spam. So, regression is for continuous values, while classification handles yes or no or other labeled outcomes. Mastering these concepts will provide a strong foundation for your career in data analysis. Keep learning and exploring,